All right, here's what I'm getting. 687, 722. All right, and oh shoot, 696. All right, so what the answer to this question depends on who's ordering the uniforms. So if each team orders their own uniforms, then these teams don't want to all use the same company, right? Because for the Flyers, Sporting Supplies is actually cheaper for them, although it is a little, well, let's see. No, I'm saying that backwards. Uniforms Plus is cheaper, although it is not for the other two teams, right? So, but if they are ordering them all together, so if she's ordering all of these uniforms all together, which one's going to be cheapest? Did I add those together right? Are you sure?
Yeah, I think so. $15. Yeah, let me make sure I have it.
Add those together again. Oh, and I see what I did. I typed in 770. Okay, yes, you're right. Uniforms Plus. I typed that in wrong. So Uniforms Plus is going to be cheaper if they're ordering them all together. Does it really matter that much in the grand scheme of things whenever you're buying $2,000 worth of uniforms? The $15 difference probably it's not huge, but you probably definitely need to keep in consideration things like shipping costs if they charge you any, or things like that, because it could make the difference. And I would also assume these are like equal uniforms that you're getting, because there might definitely, if uniforms or Sporting Supplies uniforms are a little bit better, you may just want to go with them for the extra $15. It's not a huge cost, but this would be important to consider. So you have just multiplied two matrices together. Did anybody use the matrix in their calculator to do this? You can. You can. So like whenever I did this, if I scroll back up here, this is how I did this problem. If I cut on the screen again, I entered these in as matrices and I multiplied them together. So I did not have my buttons going crazy the whole time. Right here's what my calculator looks like if it'll ever come up. I just multiplied my matrices. It gave me the answers. So you just multiplied matrices together, even though you didn't know you were multiplying matrices together for that. So what we're going to do now is we're going to go back, look at just like naked problems of no context, which actually to me is almost more confusing than the in context problems, and look at how to multiply matrices. We're going to do some of them by hand because I think it's important for you to see the process that is happening, but then we'll also use our calculator at the end for some of these as well. So first of all, let's talk about matrices that can be multiplied together. So matrices, in order to be multiplied together, the number of the columns of the first matrix must equal the number of columns of the second matrix, or number of rows of the second matrix. So, like, you'll have matrix A would be rows by columns, and matrix B would be the number of rows by columns. And what you're looking for is the columns of the first matrix have to match the rows of the second matrix. Okay? So these two things have to be equal to each other, or you cannot multiply them together. Also, Whenever you multiply these two together, your resultant matrix let's do this. I'm going to do RA and CA and RB and CB to show that that's rows of A, columns of A, rows of B, columns of B. So your resultant matrix is going to be made up of the rows of the first matrix and the columns of the second matrix. So it would be the rows of A by the columns of B. So the middle two have to match, and the outside two have to give you your, they will give you the order of your resultant matrix. So for these questions that you see coming up, I don't want you to multiply them together. I just want us to determine if it's possible to multiply the following matrices. And then, if it is possible, give the order of the resulting matrix. So for this, we're going to consider the order of both matrices. So this first matrix, let's see, Jade, what is the order of this first matrix here? How many rows by how many columns? 4 by 1. Perfect. And Lucas, what is the order of the second matrix? 1 by 5. So we're looking at the columns of the first, rows of the second. Do they match? They do. So our resultant is going to have an order of 4 by 5. They can be multiplied together. The resultant is going to have an order of 4 by 5. Now, what's interesting with this, in everything pretty much that you've done before, multiplication, the order does not matter, right? What's that property called? Commutative property. So the commutative property tells us that 2 times 3 is the same as 3 times 2, right? Doesn't matter what order that we do that in. But is matrix multiplication going to be commutative? Because if I switch this, if I try to do a 1 by 5 times a 4 by 1, can I multiply those two together? I cannot. Middles do not match. So matrix multiplication is not commutative. You cannot switch. Well, sometimes you can switch the order. Like if I have a 2 by 2 matrix multiplied by a 2 by 2 matrix, it's okay if I switch the order. But it's not always commutative. And actually, it's not, even whenever you have like a 2 by 2 and a 2 by 2, you can switch the order, but you won't get the same result in that case. So it still would not be commutative for that. All right, let's see. Benjamin, what's our order of the first matrix for number 2? That's a 3 by 1. What about the second one? Very good. Can we multiply them together? Yes. What is our order of our resultant matrix? It is a 3 by 1. Very good. Okay. Giovanni, what about the third one? What's the order of the first matrix? Good. What about the second? Can you multiply them together? No. Could you add them together? Yes, you could add them or subtract them, but you can't multiply them. A lot of times for these matrices that you add or subtract, you can't multiply together. All right, let's look at the last one. Let's see. Rihanna, what's the order of the first matrix there? It is a 4 by 5. What about the second one? Very good. Can those be multiplied together? Okay, and what is the order of your resultant? Okay, so if these two match in the middle, that tells you they can be multiplied. Your resultant is going to be the rows of the first by the columns of the second. for that. Okay, everybody good there? Does that make sense? So that's the first thing to look out for, because sometimes you can't multiply the matrices together. All right, so here is how we multiply matrix together. In order to multiply matrices, you must do the dot product of each row of the first matrix times the column of the second matrix, and that is going to look like this. So rows come from the first matrix, columns from the second matrix. So this is row 1 times column 1. So that's going to go in this spot. This is row 1, column 1. Right? That goes in that first spot. And to multiply, you would do A times E plus B times G. So that A, E, B, G. And that would give you that spot. Then, I'm going to erase this. Let's use a different color. If I want this spot right here, I need to do row 1, column 2. Right? Because that is row 1, column 2 in this matrix. So I'm multiplying the first row here by the second column here. So let's label this over here. This is row 1, column 2, and that would be A times F plus B times H. And if we keep on with this, let's use a different color here. For this spot right here, that is row 2 and column 1. So that means we would be multiplying the second row times the first column here. And so that would be C times E plus D times G. And for the last one, if we're looking for this spot right here, that's second row, second column. And so row 2, column 2, and you would do C times F plus D times H. It's a little bit of a complicated process, really. I always get a little mixed up with it, and have to sort of reset my thinking every time to remember which way it goes. But once you've done a few, it's not too bad. So let's do a couple together, and we're going to do these by hand, long ways, okay? And I'm going to write out everything right now because I want you to be familiar with the process, okay? So first of all, let's think about our dimensions. I've got a 2 by 2 times a 2 by 2. First of all, can I multiply them together? Yes, middle match. What will I get? A 2 by 2. All right, so I'm going to write every step here. You don't have to, but I'm going to, so it's clear here. My answer should be a 2 by 2. So what I'm going to do first for this spot right here, that's first row, first column. So I multiply first row by first column. So that will look like this. I will do 1 times 1 plus 2 times 1. There. So that gives me my first spot. And I'll figure this out in a second. I'm going to get everything written down first. So then let's move to the second spot. That is the first row, second column. So I'm multiplying the first row times the second column. And that will look like this. 1 times negative 5 plus 2 times 1. I've already had a piece today, Isaac, so I better not eat another one. But thank you very much. Yeah, maybe I should have just got it for you guys. All right. this one right here is row 2, column 1. So that is going to be -1 times 1 plus 0 times 1. And our last one we've got to find is row 2, column 2. That would give us this spot right here. And so that is going to be -1 times -5 plus 0 times 1. And so now you just have some arithmetic to do. You're going to get 3 in this spot. Got -5 plus 2. That'll give you a -3 in this spot. This will be a -1 and a 5 right there. Okay, everybody good there? Let's do one that doesn't have equal measurements, because I think those can be even a little trickier. So for the second one, this is a 4 by 2 matrix, and this is a 2 by 3 matrix. So first of all, can you multiply them together? Yes. What are the what's the order of your products going to be? 4 by 3. So I'm going to make myself a matrix here, and I should have 4 rows and 3 columns. I like to actually put the blanks here to make sure I don't skip something. It's easy to mess these up because you're doing so many calculations. They're all, like, every calculation is easy in and of itself, but there's so many of them. So I'm going to run out of highlighter color, so I'm not going to try to highlight on this because that's too many places. So like for this first one, you're multiplying row 1 by column 1. It's going to look like this. You're going to have 0 times 0 plus 1 times -1. And then for the second row, you're going to have 0 times -1. I'm sorry, second column, 0 times -1 plus 1 times -1. And for the last, you're doing 0 times 1, or 0, 1, and 0, -1, so it's going to be 0 times 0 plus 1 times -1. So we're done with that one. I'm going to mark it out. We've done that first row. Next row, 3 and 4. So it's going to be 3 times 0 plus 4 times -1. Then 3, 4 times -1, -1. So we'll do 3 times -1 plus 4 times -1. And for the last, we'll have 3 times 0 plus 4 times -1. There. Now, do notice something right here. What do you notice about the first row and the third row? They're the same, and these columns aren't changing, right? It's the same. So you're going to get the same results on this next row right here. So you're going to have like 0 times 0 plus 1 times -1. 0 times -1 plus 1 times -1, and 0 times 0 plus 1 times -1. So if you see a row that's the same, you can kind of just like repeat there because it's going to be the same. And then for the last one, I'm going to have -5 times 0 plus 4 times -1. I'm going to have -5 times -1 plus 4 times -1, and -5 times 0 plus 4 times -1. And then if we just do our arithmetic here, we're going to get -1. I think you get -1 all the way across that first row. You're going to get -4, -7, and -4 for the second row. the third row is going to be the same as the top row. It's just going to be negative 1, negative 1. And then you'll get negative 4, positive 1 right there, and negative 4 for that. Yes. For like that bottom row, you're multiplying, like for this spot right here, you're multiplying this row by the first column. So it's negative 5 times 0 plus 4 times negative 1 for that. So that 0 right there in the top is where it's coming from. Notice the middle one doesn't have a 0 because that column doesn't have any zeros. But then there's another 0 over here because that column has one. Now, nothing about this is terribly difficult, really, in and of itself. You're just multiplying and adding, right? But, as you can imagine, it's kind of difficult to get the right answer on these problems because you're doing so many of these things. Now, whenever you see that being your issue, it is really a place for computers to come in, right? Because computers are really excellent at doing repetitive processes that we know how to do very well, but we just get sick of doing it, right? Sort of things like, if you want to multiply 4,622 times 147, right? The process is not that difficult. You guys could do it, but the chances that you do it all the way to the end and get the right answer are low. So that is where it is a great idea to have a computer, particularly probably a tiny computer, a calculator, to do it for you, right? So same thing's going to be true here. It's going to be helpful to use the calculator for a lot of these. I want us doing a few by hand, but we're also going to use the calculator mostly just because it's tedious. Doing 1,000 of these or bigger ones of these is not going to make us any better at understanding matrices. But I do want us to do a few so we see what's happening. Now, let's go back to the first question before we do the last question here. Let's go back here. Because in this first one, even though you did not know it, you were multiplying matrices. Because if you think of this number right here, 687, you are multiplying 28 times 6 plus 36 times 11 and 41 times 3, right? You multiplied that row times the top row times the first column, right? That's what we did to get that value. We said they got $28 and they're getting 6 smalls, plus they got $36 and they're getting 11 mediums, plus $41 and they're getting 3 larges. Right? That's how we got this answer right here. Now, I'm not going to go through and write that out for every one of these, but you were multiplying row times column. So I want you to notice something here. First of all, this was a 2 by 3 matrix. This was a 3 by 3 matrix. When we multiply a 2 by 3 and a 3 by 3, we're going to get a 2 by 3, right? And not only that, but these two right here were in the middle. Those should match, right? So with these 3 right here, the columns, that was small, medium, large. The rows right here on the second one, that was also small, medium, large. It is possible for you to have 2 tables that you could multiply together, but if you do it, it's nonsense. It doesn't really make sense. So like, for example, if I got small, medium, large here, and table B has orange, green, and yellow over here, you could multiply these together, but it wouldn't make any sense to do it, right? So these two match. Now also notice this, the resultant matrix is going to be 2 by 3. 2 was the store, right? These were our rows right here. Notice that they are our rows on our final answer. And then this is our columns here, which is our teams. Notice that that becomes the columns on our final answer, right? So if you set your data up correctly, you can just use multiplication for this and just put it into your matrix and multiply it together, and you don't have all that tedious multiplying and adding there. Because did any of you on this first one, you got some of them right, but you missed some of them for that? I saw a couple of you that like had a wrong number in a spot because you're just pressing the wrong buttons probably on a lot of those. So the calculator can kind of like take some of that uncertainty out of it. Well, let's look at doing another application problem. Okay, so and a lot of times when I give you like word problems, they're so simple we could do it pretty well by hand. Like it wouldn't be that hard to do it by hand. But I give you more simple problems because otherwise I'd have to give you one that's way bigger and you got to type in all these numbers and you're still kind of likely to make a mistake. But think about scaling this particular up. We got a bakery and they sell apple, cherry, and blueberry pies, right? And then we got Monday, Tuesday, Wednesday, Thursday. But you think about scaling this up to be all Little Debbie cakes that you could possibly make and Little Debbie kind of numbers, right? So, Little Debbie, they've got way more different varieties that they're going to sell, right? So this column would be way longer. And you might be looking at days or you might be looking at stores or something like that. But your columns up here are going to be way bigger and just a lot more data to deal with, all right? So definitely doing this not by hand but by matrices would make a lot more sense if it was a lot larger. So let's think about the case, and I want to do this with matrices, not by hand. By hand is not all that difficult to figure out, but I want to do it with matrices. So the table below gives the number of apple, cherry, and blueberry pies sold. They make a profit of $3.55 from the apple pies, $5.15 from the cherry pies, and $3.95 from the blueberry pies. Find out how much money the bakery made each day. So, I want to know how much money the bakery made each day. That means that I want my answer to either be like this. I want it to tell me the money on this column, and I want Monday, Tuesday, Wednesday, Thursday across the top, right? This is what my table looks like. I want this, or there's a possibility maybe I want money right here, and I want Monday, Tuesday, Wednesday, Thursday along this axis. It's going to be one of those two, right? So let's think about our matrices and think about like being able to multiply. First of all, this matrix, what are the dimensions of this matrix that we've got? This is a 3 by 4. Okay? And then I've got 3 different types of pies, and I know how much each one of them costs, right? So, and there's just one variable there, how much they cost, right? So, one of the dimensions of my price matrix is going to have to be 3. So, it's either a 1 by 3 or a 3 by 1. So if I want to multiply it by a 3 by 4, which one should I use? Because the order is going to matter a lot right here. Like it's either going to be, like I got this, I want a 1 by 3, and it needs to be the first one, right? I mean, it needs to go first. Because otherwise, that's the only way I'm going to be able to multiply these matrices together. Those got to match. And if I do, my resultant is going to be a 1 by 4. So that's this option right here, where we're going to have like our money is going to be right here. And we'll have 4 spots for Monday, Tuesday, Wednesday, Thursday. So if I want a 1 by 3 matrix, that means I'm going to have the cost on this side And I'm going to choose A for apple, C for cherry, B for blueberry. I'm kind of running out of room, so we'll have the apple you make $3.55. Cherry you make $5.15. And blueberry you make $3.95 for that. And if you think about this matching, not only do these dimensions need to match, you got 3 and 3, but they need to be the same variables, right? Apples, cherries, blueberries, apples, cherries, blueberries. They match. If this was something different, like small, medium, and large pies, then it wouldn't make sense to multiply them together, even though it'd be possible. So let's use our calculator on this, because I've had enough of doing it by hand. I'm tired of it. So over here, come on. Why is it not? Oh, because I didn't drag it over to the side, right? There we go. Okay. So you first need to put your matrices in. We learned how to do that yesterday. So you're going to press second, X to the -1. That gets you to the matrix menu. You have to go over to edit, hit enter, and you're going to do a 1x3 matrix, and it's going to be 355, 515, and 395. I've already got it in from second period. Okay, everybody good there? Then you need to go do the same thing for the other matrix. You'll just go back to the matrix menu, go over to edit, this time go down to number 2 for B, and you have a 3x4 matrix, and you're going to enter your data there. Alright, then if you press second mode, it'll take you back to the main screen. And to get the matrices to come up, you're going to do second matrix A times second matrix, go down and pick B, and then hit enter. And it should give you your answer. And so on Monday, they made 111.05. On Tuesday, it's $83.80. Don't hit, don't hit anything. If you hit the over button, it'll finish so you can see the rest of the column. 45.45 on Wednesday, and 96. This could be useful. Think about like a company. They want to know like their sales of different things. Like this could be useful on deciding your hours. You might look at like Walmart might look at their number of customers at different times. Definitely back before COVID, Walmart was open 24 hours. It's still not back open 24 hours. They decided it obviously they ran some numbers and decided it wasn't worth it on that, or that cost wasn't the only thing they were considering, that workers didn't like working at 3 o'clock in the morning. So, although I think Walmart probably still has some people working at 3 o'clock in the morning, but the store's not open. Probably stocking shelves and picking out my grocery order that I sent in at 11 p.m. the night before for that. But that I plan on picking up at 8 a.m. the next day. So kind of interesting stuff. I like thinking about like how that would be useful for that. So.